Okay. What happened, man? Waiting, man. Ouch. It's running. Looks like something is wrong. Okay. Anyways, let's get started. Let's look at what we want to do. So we started with embedding, and we looked at word to vector embedding, and there are other types of embedding as glove. Something is wrong with the camera. It's pretty bad, actually. Is this because of the light? Okay, I think it's because of the light. That's okay. So, uh, we have looked at embeddings as in uh, word to vec, glow, fast text, and all these multiple kinds of embeddings. And embeddings are pretty uh, interesting. They are actually pretty good. They add a pretty good reasoning on why. Um, okay, I'll also tell you guys on one thing that is um, on generative AI that I'm planning to explore. So, and which which is one of my primary motivation on exploring generative AI to the detail. Um Matter of fact, if you just I mean, I'll not say it is very simple or anybody can do it, but if you get into, if you want to get into an understanding of that, if you understand how to prompt properly, and what are the different prompting techniques, how to fine tune an LLM model, and if you can understand the tools like LangChain, Flowwise, and other tools that are coming in. If you can understand few of the agent frameworks that are coming in right now, like Devin, Devika, and there are multiple, like there's some Crew AI. These are all something that we need to explore from the end. We're good if this understanding is, you're good. But my fundamental question is that what I want to answer by end of this learning is how the LLMs are able to um, respond to a given question. That is what I want to answer. So, working backwards, they say, okay, this is all basing on the transformer architecture. Okay, the transformer architecture, the basis of transformer architecture is the attention paper that is there, and they are in turn they are there is an evolution from encoder decoders, and then there's an evolution from LSTM, then there's an evolution from RNN, and where did RNN come from? So like that, there is a flow. Uh, we need to understand the flow. That's one thing that I'm focused on. Second thing is how. So if I ask a question, it is able to tell me an answer as if humans are responding to me. A question, I'm sure it would not have seen that question. Few of the questions it would have seen a similar question, but there are certain questions which it would not have heard for sure, like some questions which are outside the thing. For such kind of a questions, how is it able to respond, right? So, and that too in a sentence that is properly formed grammatically, and it could be presented in different ways, so that it because there could be a question and answer in Stack Overflow, Wikipedia, and all that stuff. There could be question and answers to this, so that's not a big deal. But again, it could um, present that question as if some person is some character is presenting it out, or as if a doctor is explaining, as if you're explaining to a kid, as if you're explaining to expert, or any kind of modulation is able to generate. This definitely I felt is where it got some level of intelligence. So the my exploration of digging deep, why is that I'm going deep into understanding things, is to have uh, to figure out that piece part of it. I'm not sure we'll be able to find it. Is it something which is hidden, people don't know it or something like that? Okay, so that's my intention of why I'm going very deep into each of these topics. um, is it necessary for people to go into this deep? mm, I would actually say it is good for people who are there in long term, especially if you want to be part of a large scale implementation and stuff. This level of a deeper understanding of the concepts is very good. But if you are more like an applied AI, where you take the AI models and apply them somewhere, um, that means you're able to understand a use case, and then you're able to map this, that saying in the AI space, this is are the kind of solution, this solution is very apt for this particular problem statement. That kind of a solution consultant, or AI, generative AI implementation consultant, that kind of roles and stuff. You don't need to go this deep. This may or may not help you. If you can go, it is good. But if you don't go, also it doesn't stop from implementing your problem. But this level of a deeper understanding will give you much. Um, I wouldn't say, but maybe even if this level of deeper understanding could be a basis for you to build your own LLM models for somebody. Like individuals building LLM models is practically not possible at this point of time, because from the scratch is not possible because of the requirement of heavy data that it needs. Heavy compute that it needs, and maintenance and stuff, it's very pretty heavy. So I'm not sure, but I don't think individuals can build capable LM model. So that's where there are companies which are building, which are investing heavy on this LM models and stuff to prove their presence. Smaller companies, what they do is they take the current LLM open source models, and they fine tune it, they train further on it, and they make it specialized for a specific domain and stuff. And then that's how they are bringing up new models with new names. But there is baseline, there is some model on top of it, similar to programming languages, right? There are the programming languages, the way they have evolved is there is some basic uh, languages like C, C++. Those all came in, and people started building programming language on top of it. So underlying the framework that the programming language uses, like the interpreter for .NET, Java, compiler or interpreter for these programming languages is underlying. There is some baseline that is built, and on top of it, they have built other languages kind of stuff. So that kind of pattern also evolves here. There are some base LLM models which can understand language, which can answer in specific language, which can uh, which have a basic understanding of a language. So in generic sense, so that kind of are taken as baseline, and those could be fine tuned to answer to have knowledge. It's very interesting for me to say that someone is having knowledge. uh, Usually we use the word memory because there is memory, and somebody has all the references of the memory. But now we are talking about feeding in knowledge to models. That itself is great. Okay, so that's the thought process. But now, coming back on that story, what I have observed is embedding is going to be a very strong contributor to the so-called um, point that we want to reach, where it would say on what is the how are the models able to predict or generate answers for unknown questions? That's the um, point that we want to arrive at. So embedding is pretty critical. So as I want to spend more time on embedding um, and understand how the embedding is working to the detail, so that because that is partial part of my answer is what my thinking goes at this point of time. But by end of this journey, I think we will uh, sum these together understandings of how things are working. um, so even if you look at LSTM and stuff, so uh, there are group of words that are given as input. For the given group of words, we represent them as some numbers. These numbers for these words are I mean, baseline numbers are okay, but the embeddings will end up producing for each word. They give you a vector. Let's say not just single number, but they'll give you a set of numbers, which in turn can be passed either to single layer of LSTM or multiple layers of LSTM. So the vector can be distributed into multiple layers of LSTM. But the objective is that single word is not represented by one single number, but is represented by a list of numbers, and these list of numbers are the standard baseline, right? For that particular embedding model, if you give similar list of words, you will get similar vectors. That should be it. This should be validated. Once you have embedding working session, I want to see that. uh, I think it should be like that only, because um, it can be something different. If it is what is your name, the embedding vectors that represent these words, what is your name, should actually have similar numbers. That's my understanding. But let's look at it. But maybe if you use different embeddings, the vectors will be different. Like for example, if you use word to vec, if you use fast text, if you use glow and all that, you'll have different numbers for different same sentence with same words. But we need to understand that process. And also, if the embedding is done on glow, and if the model is if you're using a current model and the model training has happened on, let's say, word to vec, how does it work? So my thinking goes that it should not work. The embedding that the model is trained with, and the embedding that we generate on our own embedding that we generate, if you pass it, it will not be able to answer the questions as is my understanding. So there is embedding is definitely a strong prerequisite, and it will be mapping to the model. For example, for ChatGPT, it has its own embedding endpoint, and usually what we need to do is we can't directly ask a question to it. What it does is it takes our question, and it passes that question to its embedding service, and then it will generate the vector for that particular sentence, and then that is used as input to generate the response. So that's how it is a two-step process. Um, so embedding we have seen partially word to vec. So, but we need to cover deep into it. Um, List of embedding techniques. I think we look for them. List of, I need to move to the embedding. Next. So I asked a question on what embeddings are used by GPT and its open source. So big models developed by OpenAI use contextual word embeddings. That's the context. So you should understand what are the fundamentals of contextual word embeddings. But it was self-explanatory to capture contextual relationship between words is the input sequence. These embeddings using large-scale language models, objectives, or indeed open source, and they are where it's important to contact well. Various national. No, it's in past. Hugging face. So these five things should be these five things should be there as a list somewhere. But this should be our target. Okay. Once we understand embedding, let's ask the question to someone. Say, someone doing and one practice and so on and so on. I think that's it for today. We'll wrap it up. We will focus on the embeddings, word to vec, glow, fast text, BERT, and Elmo. That be your target. Mm, here. So that will be our target. Word to vec. So one day for five of these: word to vec, glow, fast text, and BERT, Elmo. Five of these will take 5 days. We'll explore each of them in detail. And also try to understand, pick up each, and then try to go through a video offline to understand it in detail and stuff. And we'll start off with that understanding. As it said, the next steps is to understand the encoder decoder networks. Next, we'll go to attention paper, and then we'll go to transformer architecture. And I think we're good to go. Embedding, encoder decoder. For decoder, we have partially understood because there is already an explanation on sequence to sequence models and stuff, but we'll again focus on it. And then attention paper, and then transformer architecture. I think we could with that. We can jump into the actual starting exploring on different LLM models, different papers that are published and stuff. Okay. Thanks everyone. Bye.